All right, we're going to be talking about agronomy here, right? How we can set up a high yield potential for our crop, right? And if I were to ask you, when are we setting up the yield potential for wheat? What time in the growing season? Fall, right? Early, very early, right? And I would say again, as an agronomist, my thinking is at the time of planting or before, right? When we put the seed in ground, we want to have that seed the potential to provide as much as possible, right? After that, we are protecting that yield potential, right? We are looking into fertility, we are looking into disease control, we are looking into weed control, right? So you have been hearing about all of that today, right? So we're going to talk about how we can set up the plant for that max potential from the get-go, from day one, right? And it happens at the time of planting.
Right.
So you can see a few points that I have over here are going to be focused on that. Planting time, how many seeds we got to be putting out in the ground, what equipment we can use. You can see a bunch over here that we have been using, and then we'll end with the variety selection piece, right? That's the most important component, right? In a way, I'm sure Eric already talked a little bit about that, but I'll bring this new idea that we are chasing, and I believe we can get that next 5 bushels, going to that idea, right? So if I think about all these points I told you, to me the unifying factor in setting that high yield potential is having that canopy, that can maximize our light interception early in the growing season, right? I think about plant as a solar panel, right? These are the most efficient solar panels that we have, right? So the goal is to develop that solar panel, that can maximize that amount of sunlight coming in. But the job is not done there, right? We need to convert that energy into biomass and then convert that into the grain that we are chasing at the end of the year, right? So how we go about do that? And the most critical aspect we are finding in our research is the timely planting piece, okay? You can see it over here. It's part of your handouts as well. We have done this research over multiple years now. We start around here the Haitian fly free date, right? That's a good rule of thumb, typically. We start here, we plant every 2 weeks or so until mid-November or so, right? If you look at the slope of these lines, you can notice that when we are able to plant by October 1 or so, we are able to maximize our yield potential. We are higher than 90% or so, right? When we get delayed into that mid-October or so, we are already losing, right? But we are still around 80% or higher in terms of yield potential. Once we are after mid-October, now we are less than 80%. So we are sort of losing the game already, right? What we do in season might not matter as much. So that shows you the importance of timely planting, right? But what's the number one factor? If we want to plant wheat early, what are we thinking? What are the challenges? Weather is one, right? If it's raining, we just can't get in ground, right? How about the crop rotation? Most of the wheat is going after soybeans, right? If we can't get soybeans off the ground quickly, now we can't plant wheat on time, right? So this year, Christy and I are starting a project looking at what we can do to get soybeans off the ground quicker, right? Harvest aids, right? Some of you probably have used that in dry beans, right? So we are looking into the potential of using desiccants on soybean, what product to use, what timing, how early we can apply it without losing soybean yield, right? So again, we'll have some data on that aspect to help get in ground early. And then Patrick will talk a little bit about planting methods, what sort of planting method, planting equipment we can use to be able to plant early in that growing season. All right? Any questions, comments there? That's number one, to me very critical, right? In setting up that high yield potential. Number 2 over here, you can see a lot of data in this figure on seeding rate. So just like the first trial, we have done this over the last 3 years, where we plant every 2 weeks and we go from almost 500,000 seeds all the way to 2.5 million seeds. And we see what the optimal is looking like, right? Maybe let me ask you, how many seeds are you dropping in wheat? 1.3 million. Anyone else?
1.8.
1.8. Do I hear 2? Go for bidding here. No. So again, relatively high rates. it does depend on, if you have a yield limiting factor in your field, you probably need to go higher. But if you look at those numbers in the figure and the table I put it in there, again, part of your handout, you will see that we are finding out that there's a potential for us to cut down seeding rates in soybean, right? In wheat, actually. It's similar to what we are finding out in case of soybeans. So to me, soybeans and wheat behave relatively similarly in terms of seeding rate response, right? A wheat plant tells us out, a soybean plant branches, right? While corn doesn't do any of that, right? And we need to babysit that plant more than probably wheat or soybeans, right? You can see most of these curves, planting early over here or over here, they're pretty flat. As we are going to higher seeding rate, we are not gaining much, right? So that's one aspect we are finding, that if we drop little fewer number of seeds, the plant has more spacing around it. The tillers it's producing are able to become productive tillers, right? And not have those little tiny ones that really don't contribute much to yield, right? So what we recommend is try out a, let's say 20-30% lower rate, put out some strips in your field and see what it does in your yield environment, right? And see if there's you can benefit from that, right? Any questions there, comments? So we have a lot of data now, and again, this is coming from conventional till, right? No-till, we have few trials, at least some on-farm trials, where we have seen that, again, there isn't as much of a benefit of going to higher rates, but again, you probably need a little bit more hedge, going a little higher than what we are pointing here might make sense, right? The number 3 aspect here we have is looking at the planting method, right? What equipment we are using to get the wheat in ground. And we have been using a drill for forever now, right? Unlike corn and soybean, where we have had a lot of technology, right, going into precise placement of that seed, right? And there's a benefit there, right? For sure in corn, where we need that every plant to be at V2, V3, and there is a benefit there. Soybeans maybe a little less. And I believe wheat might behave similarly. One thing we are finding out is if we go to a different planting system, we can go, if we are able to figure out a way to go to narrow row spacing. That's where we are finding the most yield benefit. You can see that on our last figure over here, right? 7.5 over here, and this narrow row spacing, 5 inches or maybe even less than that. And you can see a trend there, that we are able to improve yield by about 10% or so. That research came from small plot work that one of my grad students did a few years back. So we wanted to take this on farm and see, in your, at a farm scale, can we really replicate these? And Patrick has done some work, and I'll let him explain what he's finding out, looking at precision planting and even this other planting method that we were trying to test out in terms of able to plant quickly early in the growing season. So Patrick, you want to go ahead?
So with your typical grain drill, these illustrations kind of show what sort of distribution you get with different planting methods. So with a typical grain drill, you're going to get a random distribution. Oh, he gave me one. You're going to get a random distribution of seeds within the row. Our ideal distribution would be having uniform spacing all the way around each plant, right? Over here on the right. With using a precision planter and narrower row spacing, the precision planting allows you to get more uniform spacing between the seeds within the row. And by moving to a narrower row spacing, you're reducing the large space between the rows, and therefore you're able to increase the smaller space between the seeds within the row, getting those two measurements a little bit closer together and a little closer to this uniform distribution where it's same spacing all the way around. What we've been finding with on-farm trials, if you look here on the back of your handout, is we've been seeing about an 8 to 11% higher yield with precision planter and 5-inch rows using a precision planter at 3 out of 6 site years. comparing precision planting to a grain drill. The third planting method we're looking at is broadcast incorporation, where we broadcast the seed over the field and then incorporate it with some sort of shallow tillage implement. And we have some demonstration plots here of the different planting methods and then the equipment that we used to plant them. At different farms, we were using different equipment depending on what the farmer had available. So with the broadcast incorporation, you get a random distribution of seeds, right? Which breaks you away from this row pattern with the wide space between rows and small space between seeds within the row. And it might get you a little bit closer to this uniform distribution by doing that. But with broadcast incorporation, because you have no depth control, you get a lot of variation in seeding depth, which is a potential downside of this. What we've been finding, though, in our trials, at so far all 10 site years that we have yield data for, is that broadcast incorporation tends to yield pretty similarly to grain drill. And we think that's because by having more space around the seed, each plant is able to produce more tillers and make up for any yield that you might otherwise lose due to the non-uniform seeding depth. We've also been looking at if we increase the seeding rate with broadcast incorporation by 30 or 35% to try to make up for the variability in seeding depth by increasing our seeding rate, and we haven't seen any difference between seeding rates by doing that.
All right, so again, shows you again, comparison of the planting methods, right? Short term, if you're trying to figure out how to plant timely, the broadcast incorporation probably has a potential, right? But if you're thinking longer term, how I can gain that extra 5 bushel in my wheat production, investing into a narrow row system to me is where the game is going to be. That if we are able to go narrower than what we currently are, there is a yield potential, a potential gain there. It's a systems approach. There are probably other components, and we'll talk about one here soon. But I believe that's the best case scenario longer term. Cutting down a little bit on the seeding rate, going to narrow row spacing, and able to plant early in that growing season, right? We did, you want to talk about that R7 soybeans?
Yeah, so last year at this field day, someone brought up the question of what if you broadcast with a plane into the soybeans at R7 to get the seed there, even if you're not able to necessarily harvest on time to get to early planting. So we did one of the plots here is kind of demonstrating that. We just went and broadcast by hand into the soybeans at about R7 to see what would happen if you tried that method. So you can broadcast it and then harvest the soybeans after that. And we'll see what the yields look like. The stand looks a little thin right now, but yeah, we don't have yield data obviously yet on that.
It's doable, but again, I think that your seed placement is not as optimal, right, as you can do otherwise. But again, if you're hurting, if you can't really get soybeans off the ground, and you want to stay on the left side of this curve, right, if you want to be on here, it's a possibility, right? Weed control to me is going to be a challenge there, and Christy probably has some answers there if someone wants to try that out. All right, any questions? Otherwise we will move to our last point here. Any comments on the planting methods? We actually have a quick comment. So the system you're seeing over here, we developed this, it's a 10, you can see the rows are, row units are at 10-inch spacing, right? So we had to double plant to get into a 5-inch row spacing. And that's no fun, right? Sometimes we were able to getting 5, sometimes it was 4, 6, 2, 8, or it could be sitting on top of each other, depending on how the GPS worked that day, right? So this year we did partner with the KBS Brook Wilkie over there. We had a ground money, and we did build a new planter that had 2 gangs on it. So we are able to offset and be able to plant in 5-inch rows in one pass. and we'll put some plots out there using that system. So I'm pretty excited about that, and see testing something like that, of one pass, and really see what the potential benefits are going to be. All right. The last component I want to touch here is the variety selection, right? That's probably the first one, I mean, in terms of making decisions. And maybe I'll ask you all, when you're thinking about picking a wheat variety, what's the number one factor you're looking into? Yield, right? That's always going to be on top of the mind. What else after yield? What are you thinking?
Standability.
Standability. What else?
Disease.
Disease, right? Disease package, especially if you have had scab issues out there. What else? Probably it. Maybe maturity, right? Does anyone think about how your variety is going to look like? Probably no, right? This is not even on your seed tag. So there is again a lot of research in the corn world back in 60s, 70s, and you can probably see if you look at the corn plant now, how does it look? The leaves look like this or this or this? More like this, right? We have more erect leaves. The idea is we are able to penetrate sunlight through that canopy, so the lower leaves are not getting shaded out and they're able to contribute, right? Well, that concept has worked in corn, and one of the reasons we are able to push to a higher seeding rates in corn, right? Every year we are gaining about 200 to 300 plants. That's a US average, and contributing a lot to our yield gain over the years. No one has really looked into wheat. Is there a potential in wheat varieties? Can we really breed for these more erect types that will allow more sunlight to penetrate into your canopy, right? So Eric Olson and I have been working on this trait, and it is genetically controlled. So he has genes that he can look into, that control this trait. So we are pretty excited to really look into this aspect, and think about, how, especially like if we're thinking about intensive management as an example, right? They were developing this really big, thick canopy. It's going to shade out the bottom part, right? So if we use a variety that looks more like this, it's going to allow light to pass through that top layer and get to the bottom leaves that are shaded out and respiring actually, and causing a yield drag, if anything, right? So we are looking into this aspect. The actual plots for the research are down at the Mason farm, and will be down there after lunch. So if you're interested in this, I'll highly encourage you to come down and look over those plots and see what we are looking into, right? The idea is, again, going back to the system level, if we are able to go to narrow rows, we can cut down a little bit on the seeding rate and maybe pick some of these more erect leaf types. So now we are designing that canopy that's intercepting more light, but it's not shading out the bottom, right? So you're able to convert more sunlight into biomass and eventually grain. So that's where we believe that we can gain those next 5 bushels or so, but going back into the systems approach idea. All right. Any questions, comments there? Anyone else? Anything else you guys like to add?
I have a question.
Yes, sir.
Do you have multi-year yield comparisons on planting fly-free dates versus post?
That's a good comment. So going back to the planting date, right? I didn't bring that in. So the data I'm showing over here, we started actually at fly-free day. So we did not plant before fly-free day. And we have been thinking about it this year, what happens if you plant before? The data I have seen, it's a little old, and it does show that it's actually cursed, it can curve down. Because if you plant too early, what happens is we don't have the Haitian fly issue now, right? We really don't have too much of barley yellow dwarf virus either, but we can get in theory too much tillering, and it can lead to some disease development and even some winter kill issues, because the plant has already spent a lot of energy developing more tillers. But we do not have data, and we plan to actually do those trials this year across states. Actually, we're thinking here, Ohio, so we can get that nice latitudinal gradient to really see, is there a benefit of going before Haitian fly-free date, and is there a negative as well? My feeling as of now, or my thinking is there can be a potential negative there. Anyone has done that? Anyone has any thoughts on that, planting before Haitian fly-free date? Let's say 1st of September. Do you have any experience?
I don't, but I know they can plant it, they're planting.
Okay, so they're planting. And it might, so again, the data I've looked at is old. So it might just work out. I think there might not be a yield drag there. Is there a yield benefit? We don't know. So hopefully we'll have some trials in ground this year and we can get to the bottom of it. Anything else? Yes, sir.
Who determines and how do they determine the fly-free date?
Good question. Who determined fly-free date? I don't know the answer. I know when was it done. You want to take a guess? How long ago? Probably even before you were born. I think 1910s or 1920s. So that was done a long time ago. So I don't think that number or that date is as relevant nowadays. It's a good, like a loose rule of thumb that we sort of use. And typically we can't get in ground before mid-September anyways, right? Because soybeans are still out there, right? But we, again, that's part of the same question he was asking. We are trying to figure that out, that do we need to reevaluate this? Because that was done a long time ago by a researcher.
You're probably the wrong one, but have they done a long study on planting wheat early after soybeans? You plant an early variety and you lose some yield sometimes.
Yep.
Has
So
anybody
we-
kept a chart and figured out?
Yeah, so we actually have some data. We have done some work. So the comment is like on soybeans, if we use early maturing variety and get it out of the ground and then be able to plant wheat early, right? So we have some data on that, and I think we have put an article on that. It's publicly available, but there is a yield penalty, especially like if you have ground where you can plant soybeans early in the growing season. We have seen that planting actually a late maturing variety does benefit, that you can get to a higher soybean yield potential. But if you have ground where you can't really plant soybeans early, I think that does work, that you can cut it down. You can go to let's say half a group early and not get a yield penalty on soybeans and gain maybe 5 to 7 days. That can help you plant wheat early.